Okay, this is the P2 paper from January 2023. It's question number 7, and this is a sequences and series question. In particular, we're going to be looking at a geometric sequence and the sum to n terms of a geometric sequence. Let's have a look and see what they've told us then. So for part A, they've said, a geometric sequence has the first term A and common ratio R being greater than 0, so that's relatively standard. Given that the third term is equal to 20, and the fifth term is 12.8, can we show that R is equal to 0.8? Yeah, hopefully I think so. Let's just write down the information they've given me. So if they told me the third term, remember the nth term of a geometric sequence is AR to the n minus 1. So if they've told me, I'm going to get rid of that, if they've told me the third term then is AR 3 minus 1 is 2. AR squared is equal to 20. And then they've also told me the fifth term, so that's AR4, they've told me that's equal to 12.8. Well, if this was the first time we'd seen one of these questions, we might struggle with it, but hopefully you've done enough practice of these to see that if I now do 2 divided by 1, I'm going to get AR to the 4 over AR squared, and the A's will cancel. R to the 4 over R squared is going to give me R squared. That's equal to 12.8 over 20. So in other words, R squared is equal to what that works out to be, and that's 0.64. And 0.64, so it's a square number, isn't it? 0.64 squared. R squared, sorry, is 0.64. Do square root, but you might even be able to just see that. R works out to be equal to 0.8, and we were asked to show that for the first part, so no problem with that. Part B says let's go on and find out what A is. Well, remember we know AR squared is equal to 20. So if that's true, A times R squared, 0.64, is equal to 20. So A is just 20 divided by 0.64, and that works out to be 31.25. So we've done part A and part B there. Then what does it say? It says, given that the sum of the first n terms of this sequence is greater than 156, what's the smallest possible value of n if it's greater than it? Okay, well, let's find our formula for the sum of n terms. Our formula for the sum of n terms is Sn is equal to a 1 minus r to the n over 1 minus r. And what I'm actually going to do is I'm going to set that equal to 156, and then I know my number will have to be the next integer bigger than that anyway. So if that's the case, we've got 31.25, 1 minus 0.8 to the n all over 1 minus 0.8 is going to equal to, handwriting, sorry, it's going to equal to 156. And I'm going to be able to solve this. I'll need to do some log work in a second. But on the bottom, I've got 0.2 there. So 1 minus 0.8 to the n is just 156 multiplied by 0.2, but divided by 31.25. So 1 minus 0.8 to the n is equal to, that works out to be 0.9984. Swap those over then, 0.8 to the n is equal to 0.0016. And now how do I get rid of that power out of there? Let's just log both sides. Log 0.8 to the n is log 0.0016. I can use my log rules now to bring that power down. This is all stuff you should have done plenty of times before, so I'm going to get n log 0.8 is equal to log 0.0016. And so n works out to be that one divided by that one, log 0.016, all divided by log 0.8, and n works out to be equal to 28.85. So what that means is, as these terms were getting bigger and bigger, starting off at whatever the first term was, 31.25, as the terms were getting bigger and bigger, somewhere between 28 and 29, the 28.85th term, if there could be such a thing, there can't, but if there could be such a thing, that's where we get our sum equaling to 156. So what were we asked for? We were asked for the smallest value of n that works out to be bigger than 156. So it's going to be our n equals 29. So that's just to explain that, but basically as soon as I got 28.8, was it 20.85, 28.86, yeah, 28.85, n would have to be 29 for those circumstances to be true. Okay, so that's number 7 done. Hopefully that's relatively straightforward and makes sense to you all.